Welcome to another unit of the ISM exercise set Business Mathematics, this time with a unit on Lagrange multipliers. Let's have a look at the exercise. Here it's calculate all possible extrema of the following function, that's a function f of x and y, which also fulfill the following constraint. And here we have a constraint x minus y squared equal to 3. Before we can continue, we need to consider that all the constraints in this context, so here with equality constraints, need to be written as equal to 0. So we have to bring the 3 to the left side by calculating minus 3. Once we've done this, the next step is pretty straightforward. That's in actually building our so-called Lagrange function. The Lagrange function is just the original function plus lambda times the constraint, so the part which is equal to 0. That's why we needed to equalize this with 0. So here, instead of x minus y squared equal to 3, we had as a constraint x minus y squared minus 3 equal to 0. Okay, once we have this, we have the Lagrange function. We have with the Lagrange function an additional variable lambda, and we get one additional variable per additional constraint. Here we only have one constraint, so we only have one additional variable. When we have then our three variables in our Lagrange function, we can derive the Lagrange function for each of these three variables. So we get one partial derivative for x, one for y, and one for lambda. Well, if we work our way through, for x, we have y plus 3 plus lambda. Then we do the same thing for y. Then we get x minus 2 lambda y. And finally, we have to do this for lambda. This gives us just our constraint x minus y squared minus 3. And that's how it looks. And well, as I said, what we're going to do here is basically the same as with the normal extrema calculation, only we're doing this for the Lagrange function. So we're setting all three equations we have here equal to 0, giving us in the first one this part, which we can solve for lambda as minus 3 minus y, and the second, which then can be written as x being equal to 2y lambda, and the third one, which is basically our constraint, which we keep as it is for the moment. Due to space restrictions, I will just copy this on a second slide. Copying the three equations we just calculated on the slide before. We have those three, and we can, well, solve the first one for lambda and the second one for x. This has an advantage that we can directly see we can insert the first into the second, giving us then one equation which only consists of an x on the left and only y's on the right side. So then we just factor out, giving us here 2y times minus 3 minus 2y times the minus y. So this is then a new equation 4, which we can use together with equation 3 by just inserting 4 into 3 to get an equation which only consists of y terms, well, and numbers. So we just summarize here, giving us then the equation minus 3y squared minus 6y minus 3 equal to 0. So we divide this by minus 3, giving us finally the third of the three equations, y squared plus 2y plus 1 equals 0. Well, if we look closely at this, we see this is basically the first binomial form, meaning we can summarize this to, in parentheses, y plus 1 to power of 2 equal to 0. If we now take the square root, giving us y plus 1 equal to 0, we can just go with minus 1 and get y is equal to minus 1. Okay, so much so good. This y, this equation 5 we can use into equation 4. So we insert the y equal to minus 1 into 4, allowing us to directly calculate x as being minus 6 times minus 1 minus 2 times minus 1 squared, or rather here 6 minus 2 being 4. So we see we have exactly one solution to our systems of equations, and that's the solution x being 4, y being minus 1. So this is the only possible extremum here, and well, we found this possible extremum, and thereby we have concluded our exercise. Well, I hope you enjoyed listening to it, and if you're looking for more of these types of exercises, feel free to visit the rest of the course or take a look at the corresponding playlist. Until then, say goodbye and see you next time.